Imagine a swirling vortex of colors, a mesmerizing dance of hues and shades that seem to stretch infinitely into the cosmos. This is not just a spectacle for the eyes but a gateway to the mysteries of the universe. Stars streaking past like fireflies, each one a beacon of light in the vast darkness, guiding us through the endless expanse of space. These celestial bodies have witnessed the birth and death of galaxies, the rise and fall of civilizations. Time itself bends and twists, a fluid entity that defies our understanding. It is not a straight line but a complex web of moments, each interconnected and interwoven with the fabric of reality. A concept we grapple with, a dimension we yearn to conquer. Scientists and researchers dedicate their lives to unraveling its secrets, to understanding its true nature and potential. Time travel, once purely the realm of science fiction, now beckons from the fringes of scientific possibility. Theories and experiments push the boundaries of what we know, inching us closer to making the impossible a reality. Could we one day journey through time as easily as we travel across continents? Imagine boarding a vessel not just to another place but to another era, experiencing history firsthand or glimpsing the future. The human mind, ever curious, yearns to unlock the secrets of time. Our quest for knowledge drives us to explore the unknown, to push the limits of our understanding and capabilities. We are travelers by nature, and what greater journey is there than through the very fabric of time itself? From the vast landscapes of our planet to the infinite reaches of space, our spirit of exploration knows no bounds. But is time travel merely a fantastical dream, or could it one day be our reality? The line between imagination and possibility is often thin, and what was once deemed impossible has frequently become our new reality. Join us as we venture into the heart of this captivating enigma, exploring the tantalizing possibilities and mind-boggling complexities of time travel. We will delve into the theories that challenge our perception of reality and the experiments that push the boundaries of science. Our journey takes us from the well-established theories of physics to the edges of human understanding, where the lines between fact and fiction blur. We will explore the realms of quantum mechanics, the paradoxes that baffle even the greatest minds, and the potential technologies that could one day make time travel a reality. Imagine a world where history is not just read about in books but experienced firsthand, where the future is not just a distant dream but a place we can visit. The implications of time travel are profound, affecting every aspect of our lives, from our understanding of the universe to our place within it. As we stand on the brink of this new frontier, we must ask ourselves, are we ready for the journey? The path ahead is fraught with challenges and uncertainties, but the rewards could be beyond our wildest dreams. So let us embark on this journey together, into the unknown, into the depths of time itself. The adventure awaits, and the possibilities are endless. Welcome to the future of exploration. Welcome to the journey through time. To grasp the complexities of time travel, we must first understand the very nature of time itself. Time, as we perceive it, is a continuous, ever-forward-moving entity. It governs our lives, dictating the rhythm of our days and the progression of our existence. But what if time isn't as straightforward as it seems? What if it can bend, stretch, or even loop back on itself? These questions have fascinated scientists and philosophers for centuries, leading to groundbreaking theories and mind-bending discoveries. Albert Einstein, a giant in the world of physics, provided us with a revolutionary framework, the theory of relativity. His work fundamentally changed our understanding of time and space. Before Einstein, time was thought to be a constant, an unchanging backdrop against which events unfolded. But Einstein's theory suggested otherwise. He proposed that time is intertwined with the three dimensions of space, forming a four-dimensional continuum known as space-time. Einstein proposed that time is not absolute, but rather, it is relative. This means that the passage of time can vary depending on factors such as speed and gravity. For instance, time moves slower for an object in motion compared to one at rest. This concept, known as time dilation, has profound implications for our understanding of the universe and the possibility of time travel. Time, he revealed, is interwoven with space to form a flexible fabric called space-time. This fabric can be warped and curved by the presence of mass and energy. Imagine space-time as a vast, elastic sheet. When a massive object like a star or a planet is placed on this sheet, it creates a depression, a curvature in the fabric. This curvature is what we perceive as gravity. Imagine a stretched sheet. This is our space-time, and massive objects like stars and planets create dips in this fabric, much like a bowling ball placed on a trampoline. The more massive the object, the deeper the dip. This analogy helps us visualize how gravity works in the context of space-time. Objects move along the curves and dips in this fabric, and this movement is what we experience as gravitational attraction. This curvature of space-time, caused by gravity, affects the flow of time. Near massive objects where the curvature is steep, time slows down. This phenomenon is known as gravitational time dilation. It means that time passes more slowly in stronger gravitational fields compared to weaker ones. This effect has been observed in various experiments and is a key prediction of Einstein's theory of general relativity. The stronger the gravitational pull, the slower time flows relative to an observer experiencing weaker gravity. This effect becomes extremely pronounced near massive objects like black holes. In the vicinity of a black hole, the gravitational pull is so intense that time can slow down to a near standstill. This has fascinating implications for the concept of time travel, as it suggests that by traveling to regions of intense gravity, one could potentially experience time at a different rate than those in weaker gravitational fields. This phenomenon, known as time dilation, is not merely a theoretical concept, it has been experimentally verified using atomic clocks. These highly precise timekeeping devices have shown that clocks placed at different altitudes, and thus experiencing different gravitational strengths, tick at different rates. This experimental evidence supports Einstein's predictions and provides a tangible demonstration of the relativity of time. As we continue to explore the mysteries of the universe, our understanding of time and its malleable nature will undoubtedly deepen, opening up new possibilities for the future of time travel. Einstein's theory of relativity opens a fascinating doorway to the possibility of time travel, at least into the future. Time dilation suggests that if we could travel at speeds approaching the speed of light, or if we could linger near objects with immense gravity, time would slow down for us relative to those on Earth. Imagine embarking on a cosmic voyage aboard a spaceship capable of reaching near light speeds. Years pass for you, the traveler, but upon returning to Earth you might find that centuries have elapsed. You have effectively leaped into the future, a consequence of time's elasticity. While the technology required for such high-speed travel remains beyond our current capabilities, the concept of time dilation is a cornerstone of modern physics, offering a tantalizing glimpse into the possibility of future time travel. Our exploration of time travel wouldn't be complete without venturing into the realm of wormholes. These theoretical tunnels through space-time, predicted by Einstein's equations, could potentially connect two distant points in space and time, much like shortcuts through the cosmos. Picture space-time as a folded sheet of paper. A wormhole would be like a tunnel punched through the paper, connecting two points that would otherwise be far apart. Theoretically, traversing this tunnel could allow us to travel vast distances across space or even journey through time. However, the existence of wormholes remains purely theoretical. Even if they do exist, the immense gravitational forces at play would likely crush anything attempting to pass through. Furthermore, stabilizing a wormhole would require exotic matter with negative mass energy density, a concept that, while fascinating, has yet to be observed in the universe. The concept of time travel, particularly the notion of traveling to the past, often stumbles upon perplexing paradoxes. These paradoxes are not just theoretical musings, but are deeply rooted in the fundamental principles of physics and logic. They challenge our understanding of the universe and force us to reconsider the linear progression of time that we take for granted. These logical inconsistencies challenge our understanding of cause and effect, raising questions about the very nature of time itself. The idea that an action in the past could alter the present or future creates a web of possibilities that are both fascinating and bewildering. Scientists and philosophers alike have pondered these questions for decades, trying to unravel the mysteries of time. One such mind-bending paradox is the grandfather paradox. This paradox delves into the complexities of time travel and its potential consequences. It serves as a thought experiment to illustrate the potential contradictions that arise when one attempts to alter the past. Imagine traveling back in time and accidentally causing the death of your grandfather before your own father was born. This scenario creates a cascade of events that defy logical explanation. If your grandfather never lived to have children, then your father wouldn't exist, and consequently neither would you. This paradox forces us to question the very fabric of reality and the consistency of the timeline. This seemingly innocuous act creates a logical impossibility. Without your grandfather, your father wouldn't exist, and neither would you. The grandfather paradox highlights the potential for contradictions and inconsistencies in time travel scenarios. It raises the question of whether the past is immutable or if it can be altered by actions taken in the present or future. But then who traveled back in time to erase your own existence? This question leads to a deeper exploration of the nature of time and the possibility of multiple timelines or parallel universes. Some theories suggest that any changes made to the past could create a new, divergent timeline, leaving the original timeline intact. Others propose that the timeline would self-correct, preventing any paradoxes from occurring. Another intriguing puzzle is the bootstrap paradox, which explores the idea of information or objects appearing from nowhere, trapped in a causal loop. This paradox challenges our understanding of the origin and flow of information. It raises questions about the nature of existence and the possibility of objects or information existing without a clear point of origin. Imagine finding a musical score that inspires you to compose a masterpiece. This scenario sets the stage for a fascinating exploration of the bootstrap paradox. The idea that an object or piece of information can exist without a clear origin challenges our understanding of causality and the flow of time. Years later, you travel back in time and hand that very score to the composer who originally inspired you. This act creates a causal loop where the musical score exists without a clear point of origin. It raises questions about the nature of creativity and the flow of information through time. Where did the music originate? This question lies at the heart of the bootstrap paradox. It challenges our understanding of causality and the flow of time. The idea that an object or piece of information can exist without a clear origin forces us to reconsider our assumptions about the nature of reality. Who is the true creator? This question delves into the philosophical implications of the bootstrap paradox. It raises questions about the nature of creativity and the flow of information through time. The idea that an object or piece of information can exist without a clear origin challenges our understanding of causality and the flow of time. The bootstrap paradox highlights the potential for circularity and self-consistency in time travel scenarios. It forces us to reconsider our assumptions about the nature of reality and the flow of time. These paradoxes, while perplexing, offer a fascinating glimpse into the complexities of time travel and the mysteries of the universe.